Good morning. My name is Om Patil of class 9 and I am studying in KV CBSE Nipani. So today I am proud to exhibit my project which is ESP32 Disaster Management Alert System. But before that, did you know 1,000 people die every year because of natural disasters? It's not because we lack technology, but it's because the technology that we use for disaster alert systems are either too slow or they are too expensive for the government to implement. But my project solves that by being both affordable and providing real-time data. So let's get to the main problem. The main problem is natural disasters strike without any notice, which means that they come, cause casualties, and they provide damage to both life and property. And the systems we use nowadays have three major flaws. First of all, they're expensive for the government to implement all over the country. Second of all, they are not suitable and deployable for rural areas where the disaster hit the hardest. And third, they do not provide real-time data, and especially not to anyone like you and me. So now I have told you the problem. So you must be wondering, what is the solution of it and what components and connections has used? So as you can see here, I've used various components. But first, I would like to show you the code. So here, I've used C++ in Arduino IDE to code the ESP32. And I've also used Python to code for the AI which I'm using YOLO Y3. So now I have also started the code. So now the web server is activated. And first of all, I will turn this on. Sorry for your delay. And see, especially and in just 5 seconds, everything just booted up. And it's also booting up. So now it will take approximately 5 seconds just to boot up. And now it's officially booted up. So now I'll explain all the components one by one. Here we have an ESP32 cam, which is a live camera with an AI model loaded on it, which I will show you. Now, as you can see, it is detecting me as a human. And as we know that we cannot bring a real life model or a hurricane, so I'm just using. So now it can detect a human. So why can it not detect an earthquake, and it can prevent false alarms? So now we come on the OLED display. We displays all these sensors readings on a small display, which you can say is like a billboard. And the billboard can be accessible for all the people who do not have phones or tabs to access the web server. Then we have a SW vibration sensor. It's a vibration sensor which detects the vibration. So now if I shake it like a real earthquake, it can detect it and alert the people to evacuate from that area. And which you can see the web server has also alerted the people as an earthquake and the background has turned red. So now we have a DHT11 sensor which provides both temperature and humidity, as you can see here, and better of all I would like to show you on the web server. So here it shows both temperature and humidity. This is essential for earthquakes, hurricanes and tsunamis, as the temperature fluctuations matter the most. Then we have my favorite part, which is ultrasonic sensor radar with a servo motor. The servo motor acts like a radar, and the ultrasonic sensor uses the principle of sounds, and it measures the distance by calculating the time taken from the sound waves to bounce back. As you can see, it has provided a radar and it tells us if an object is coming in middle. So now I would like to keep my hand in the middle. So say my hand is a hurricane, it will alert the people around it and show with a dot that a hurricane was detected here. So at last I would like to show the ultrasonic sensor with the flood detection system. As you know how ultrasonic sensor works, such as and you know how tsunamis are flooded. In tsunamis the water goes back, and in floods the water comes front. So I have also defined predefined thresholds, and with the predefined thresholds it can be detected. So if the water goes back, it detects it as tsunami. If the water comes front, it detects it as a flood. And say for example my hand is a flood or water, and if say the water keeps rising and it rises before the three defined thresholds, it activates it and tells all the people to evacuate as a flood is coming. And as you can see here, it is also showing a flood and the alert system. So those were all the components. So you must be wondering, what are the features of my project and what makes my project different from others? First of all, it has 24/7 functioning. That means thanks to its solar powered backup battery, it can function for 24 hours and it can recharge in the day. After that, I using a cost-effective system by which the government can implement all over the country, even rural areas where the disaster hit the hardest. And after that, this provides a real-time web server for everyone and anyone to access. Like as you can see here, it is providing real-time data and it changes, which is most important and which is the major cause, as you know, of that. So in conclusion, this is my message to the NDMA or National Disaster Management Authority to implement such systems if we genuinely want to reduce casualties and save life and property. So this is just not a model. With a little modifications, we can detect earthquakes in Uttarakhand, floods in Kerala, and wildfires in Maharashtra. So thank you.